Good morning. We are going to discuss about the introduction and course outcomes of elements of remote sensing and geomorphology. Remote sensing is the process of gathering information of any object, phenomena, etc. without getting into physical contact. Nowadays, this technology has a wide spectrum in geology because in a field survey we have to put enormous amount of human effort. But remote sensing technology has made such surveys much easier. It saves our time, efforts, and they are economical too. Hence, multiple geological surveys are done through remote sensing. Then we are going to see the geomorphology. It is a branch of geology that studies the evolution of the Earth's surface by various agencies. As we have already seen, the various agencies which are active on the Earth's surface since our semester one. But their applied part means the resultants of the processes conducted or executed by these agencies comes under geomorphology. So let us discuss the syllabus. As per Gondwana University Gadchiroli, the elements of remote sensing and geomorphology has been allotted to BSc SEM 5 as paper 2 with a code of USGEOT 10. Following is the syllabus of the paper. Unit 1. Definition of remote sensing, scope and aim of remote sensing in geology, remote sensing from aerial heights, remote sensing from space heights. Then we are going to see aerial photography and aerial camera. Then we will see the types of aerial photographs. After that, flights for obtaining aerial photos will be our next topic. Methods of studying aerial photos in the form of mosaic and stereo pairs will be discussed, and the tool used for studying, that is pocket and mirror stereoscope, will be discussed finally. The respective outcomes of this unit will be: you will learn the basic of remote sensing, aerial photography, etc. You will develop the understanding about the aerial and satellite imageries. You will develop the skill to study the aerial photographs. Let us see the unit 2. In unit 2, the first topic will be recognition elements. So we have certain recognition elements like tone, texture, pattern, shape, size, form, shadow, drainage, vegetation, and landforms. On the basis of them, we are going to interpret the aerial photograph. Then we're going to discuss about photographic expressions of various geological features and respective factors affecting such expressions like climate, vegetal cover, soil, type of weathering, nature and composition of rocks. Finally, we'll discuss about the importance of concept of convergence of evidence in photo interpretation. This is a very important topic here, that how the different evidences are converged for the photo interpretation along with the guidelines regarding lithologic structure and geomorphic interpretations. The respective outcomes are: you will understand the recognition elements in aerial photography. You will develop a skill to interpret the aerial photographs on the basis of recognition elements, and you will learn to identify the geological features on the aerial photograph. With this, our remote sensing part will be concluded. The unit 3 is about the geomorphology. The first topic will be the scope and aim of geomorphology. Then we'll see the fundamental concepts of geomorphology, then weathering, mass wasting, and related landforms. Then we'll go for fluvial cycle of erosion, where we'll see the life cycle of the river. Then Mackinson's concept of graded streams will be discussed. And finally, drainage pattern and their significance will be studied. The respective outcomes are: you will learn the basics of geomorphology, you will learn about the fluvial cycle and their related landforms, you will understand the concept of drainage pattern and its relevance in geology, you will also develop a skill to identify the various fluvial features and drainage patterns in the field. Let us see the last unit, which is the fourth unit, and it belongs to geomorphology. Here we will discuss about the karst topography. Karst is developed by the limestone terrain. Then we'll go for aeolian, which is actually the features developed by wind action. And then we'll go for glacial cycles, the features developed by glaciers. Then we'll see the concept of morphometric regions. Then the topography developed over folded and faulted structures will be discussed. And finally, we'll go by the idea about the applied geomorphology. The respective outcomes are: you will learn about the aeolian and glacial cycles. You'll also learn about the karst topography. You'll understand the concept of morphometric regions. You will develop a skill to identify the various aeolian, glacial, and karst features and topographic features in the field. So let us summarize our outcomes. The course outcomes of this paper will be: students understand the basic concept of remote sensing and its application in basic operations of geology. Students develop the skill to study and analyze the aerial photographs and satellite imageries. Students understand the basic concept of geomorphology and the processes responsible for its formation and development. Students develop the skill to identify the various geomorphological features and its relevance with interdisciplinary approach. So thank you very much for your patience listening. Thank you.